Radio Brockley, on air 24 hours a day.
Hello and welcome to Brockley News, Radio Brockley's weekly show with news, interviews and information, including updates on all you need to know about what's happening in and around the hospital. I'm Sophie Horrocks. Tonight, we hear interviews from a recent RNOH Open Day, when the hospital opens its doors to visitors to demonstrate the groundbreaking work and research that is happening in the hospital. Then at 7:30pm, it's your chance to win some Radio Brockley goodies without leaving your bed on Bedside Bingo with David Rauch. Then at 8 o'clock, it's your choice of tunes on the Sunday Request Show with Keith Reeve. So stay tuned to London's longest running hospital radio station and the UK's official #1 hospital radio station, Radio Brockley. Every year, the RNOH hosts an open day where it opens its doors to visitors to showcase the groundbreaking research that's shaping musculoskeletal medicine in the 21st century and beyond. Our first interview is with Alistair Hart, who was showing visitors how to drill out a hole in a bone.
So you're 13?
Yes.
What's your name? Michael. So let's see if we can teach Michael, 13-year-old, how to do a hip replacement. Yeah? First of all, let's teach him how to use the power tools. So here you go. This is a reamer that we use to ream out the bone. So first of all, pull the trigger and it goes round. Good. Now put the reamer in the bone, the plastic bone. So gently, just pull the trigger. Okay, very nice. Very nice. Keep pulling the trigger, and you can gradually put more pressure on. You can see how much bone comes if you put a bit more pressure on. Yeah? That's enough. Then you get the titanium socket. Take the hammer and with one hand hold the handle and with your other hand tap in the hip replacement. Yeah, that's very nice actually. That's very nice. Let me just test that. You are almost there. So just tap once more. And again. That's it.
It's cracked.
It's cracked. So we've cracked the bone. We're going to have to fix it now. And that's why we teach people on plastic bones. We teach people how to use the power tools, how to use the right amount of force, how not to crack the bone. Now if we can teach Michael, age 13, how to do hip replacements, we've got a good chance of teaching many surgeons how to do hip replacements. What do you think?
Yeah.
Did you enjoy that?
I did, thank you very much.
What did they use before plastic for teaching?
Real bone.
Real bone.
Cadaver bone. And we still use cadaver bone. The disadvantage is most of them don't have bony problems, osteoarthritis and things like that. So the bony shapes are not that abnormal. So one of the things that we do at the RNOH is actually make plastic bones of abnormal shapes that directly represent the shapes of some of the bones of our patients. We take the CT scans of our patients and we turn them into plastic bones. And that's a fairly innovative approach to education. We've been doing that for 5 years.
You can have direct dummy runs with bones that match what you're likely to be using.
Exactly right.
I'm Yazzie Al-Jabori.
I'm Lindsay Duffel.
We're Aspire Create, so we're based here on the Stanmore campus.
And you have got quite a lot of technology around you here. Can you tell us what you've got?
This is electromyography. So this is measuring the muscle activity that's being generated when Yazzie moves her thumb.
So Yazzie is sitting in a chair and you are connected it. What did you say these are called?
So these are called electromyography electrodes. So they're placed over the muscle that controls her thumb.
Okay.
So when Yazzie moves her thumb, we can measure all of the electrical activity that happens in the muscle when she moves her thumb. So on the screen you can see all of these spikes. So each one of those spikes is a single impulse that's being sent from Yazzie's brain to the muscle when she chooses that she wants to activate
So
that
on the
muscle.
screen it's almost like voice recognition, but obviously it's muscle.
It's muscle activity,
Activity,
exactly.
yeah.
So what we're going to do with this machine, this is a magnetic stimulator.
You've got a long hose attached to a machine.
That's right.
I'm not very technical, am I? And on the end of it is a sort of circle with a hole in the middle. That's the magnet.
Yeah, this is a magnetic coil.
Okay.
Okay, and this is going to activate the neurons in Yazzie's brain via electromagnetic induction.
Gosh, very scientific.
Okay, so basically it's going to travel through her brain without us having to be invasive. We can just put this magnet close to her brain and it's going to activate the neurons in her brain. So what we know is that this area of her brain here,
The top of her head.
as if you were wearing an Alice band,
Yes.
A headband.
Yeah.
a headband, that is her motor cortex. So all under here is the area of the brain that controls all of her muscles. Okay, and this side controls her left side of her body, and this side controls the right side of her body. And then right in the center here is where her leg muscles are. And then as we go out from the center, it's her arms and her face. So what I can do is I can position this coil where I think the arm area is of her brain, and hopefully activate that muscle in her hand.
Without her doing anything.
Without her doing anything.
Okay.
Yeah, and it's rather than lots of spikes that you see here, it's going to be one single spike, which is a response to the single impulse
Right.
where I stimulate her. Okay, so this
Okay.
ticking sound, this is the magnet firing. Okay,
So you're holding the magnet.
over.
It's placed right over the head now.
So this is the area that I think is controlling that muscle. So that wave on the screen there,
Yes.
that's the response in the muscles to
So
the
every
stimulation.
so often there's a spike, isn't
Yeah.
there, and a movement
Yeah.
at the same time.
So the spike is the artifact from the stimulus, and then there's a bit of a delay while the signal travels down to her muscle, and then the wave is the response in the muscle.
And how is this useful for patients?
So it allows us to check the integrity of the pathway from the brain to the muscle.
Right,
So if somebody
okay.
comes in and says, okay, I can't activate this muscle, then I can bypass their voluntary effort and just test the whole pathway myself. And if I can activate it, I can say, well, actually, there's no problem in the pathway because I can activate the muscle
Okay.
with my machine. But if I can't, then I know that there's a problem somewhere in the pathway.
So it's part of a process of elimination almost.
Yeah,
Yeah.
yeah.
Oh, wow, that's amazing. Thank you very much.
I'm with Professor Mia Dofnik, who's Professor of Materials at the UCL. In a few words, can you explain what a Professor of Materials does?
I can tell you what I do, which is I run something called the Institute of Making, and what we do is we create research projects which are like things like helping people walk, or creating new ways of eating, or designing new methods of transport, and we then assemble multidisciplinary teams to carry out that research in our lab. So this isn't just engineers, it's not just physicists and chemists, but it's also artists and designers and novelists and philosophers, because we really believe that to actually solve human problems, you need to understand humans. It's not just a technical solution. So it's about understanding humans, getting the patients involved, and then creating that project together.
And you gave a very interesting talk earlier on here at the open day. From that, I glean that we're getting closer to materials, physical materials and human materials, if you like, coming together.
Yeah, I think the future is going to be the difference you'll see between a living tree and what you might call now an inanimate bridge or car, or road, that difference is going to blur in this next century. And there are good reasons for it. One, we can do it, and two, that things that repair themselves, like living things, tend to last longer. And it's totally doable. Because actually, the difference between an inanimate road and an animate tree or plant isn't that massive, you know.
On the medical front, I came here a couple of years ago to one of these open days and saw a mechanical exoskeleton that was very bulky. And in your talk again, you suggested that we're getting very close to making these out of basically material.
Yeah, so close is probably a difficult word because it's still 10 years away, and that's a long time for someone who needs the technology now.
Absolutely, yeah.
So I don't want to overhype it, but direction of travel is in the same way that phones and remember on an old computer and see how small they are now. Yeah. That is the direction of travel for these exoskeletons, and it's going to happen. And it's all about how much investment goes in to accelerate it, and so that means big market. If you think about how incredible the smartphone technology has happened, it's because there's billions of people. So the companies involved could raise billions of pounds to get to that market. With the disabled communities needing exoskeletons, they're a smaller community, albeit quite large actually. But if you add into them older people who want to be living independently to the age of 80, 90, 100, and the only thing stopping them is their ability to kind of have strength in their legs or their arms. You can see a whole slew of technologies that will come in, and that is 2 or 3 billion people. And so I see that companies are going to see that market opportunity.
I hope I've got a few more years left in me yet, but already I'm suffering with the aches and pains and the bad knees that I can't walk as far as I did.
But if we could make an exoskeleton you could put on that made you look completely normal, so it was underneath your clothes, but meant that you could still walk to the shops with confidence up to the age of 80, 90, 100, that would just be a huge step forward for lots of people. And it would also help them psychologically because they wouldn't feel isolated and maybe bedridden or, in their houses and therefore, lonely. So I honestly think this is a key technology that will happen. And the other thing we've heard from these people is that they don't want to look like a robot. Okay? They want to look normal, so it's got to be underneath their clothes and be quite thin and basically fit them really nicely and be comfortable. But then it just helps their legs move, helps their arms move, so that they can just behave normally. Wearable assistive technology, so it'd be like wearing an underwear, but it's got a kind of motors inside it. They won't look like motors. And it will be like a fabric.
And it will breathe, I guess, for want of a better word, in terms of where you want the strength it'll give you, where you want movement.
That's the idea.
Fantastic. Yeah. Well, I wish you all the best, and it's good to see you working with Rui and the team here as well at the RNOH.
Yeah.
Thank you very much for your time
talking
to us.
Still to come tonight on Radio Brockley, we have Bedside Bingo, followed by the Sunday Request Show, those hosted by David Rauch and Keith Reeve. But now we return to the RNOH Open Day, the demonstration of how an Xbox game can help patients with their own rehabilitation.
So this is an Xbox Kinect, which has been modified for us to rehab the whole body. So it's got games for your spinal problems, knees, hips, neck, or full body. So it's targeted towards kids a lot more because a lot of kids don't really like doing a lot of physio exercises, so how else do we get them to do it? Put it in a games format. So we have got loads of games. So we kind of choose which body part you want to work and exercise in which particular direction. All the games that are related to it will load up, and you can set how difficult you want it. Any particular games might have obstacles in it, so you can choose how hard you want the obstacles to be, and as you get stronger with it, you can make it harder and harder, and you can choose how long you want to play the game for. So do you guys want to play it?
Yeah. Okay.
Right. Have you got any particular problem area?
Yes.
No, your shoulder was...
I injured my shoulder a couple of years ago.
Okay, so let's do shoulder. Okay, shall we focus on that? So we're going up. Okay. So let me set this up for an up movement. So these are all the games that load up, which you can play with the shoulder. Okay. It's your left side.
Yeah, left side, yeah.
Okay, so and then we just do the setting. So left side, maximum range.
It goes medium, yeah.
Medium, enemies,
Yeah.
yes, full area, okay? And we'll play it for a minute.
How does it work? So
It will tell you the instructions
Okay.
of it.
The objective is to fly a dove up in the sky. Your objective is to collect fireflies that appear in your path, and then guide them to safe havens to keep them out of peril. Make sure to avoid vultures or other dangers that may come your way.
Fly. So it's very sensitive, so
careful of the vulture.
so collect the firefly, that's it, and take it towards the sun, and so you can deposit them.
Like there. Where? No, the man to right. Go down. How are you doing it?
So it's just generally moving the arm, okay? So you don't need to keep your arm down, just keep it up so it will keep it flying.
It's a great score, Ellie. It's the best score that they've ever had.
And can I ask, can the patients then access these sort of apps remotely once
At the
they're
minute,
home?
not yet. So it's predominantly used. We have an inpatient rehab program where kids come in for 2 weeks and stay with us. So that's when they can predominantly use it. And they, every time they come back for their review, they play it again just to see if they've improved. But unfortunately, they can't take it home yet because it's quite an expensive piece of kit. But that's something that we're in talks with the company. So all you need is a sensor.
And that's just a bit of Xbox kit, is it?
That's just an Xbox sensor that modified for us. So they've got a smaller one, which if we have enough funding, we can buy, and then we can give it to the patient saying, you keep one at home, give them access to the software which they can download, and then they can log in and then play the games 3 times a week that we want them to play, or twice a week, whatever. And we can see if they've played the games or not because we have got access to it here as well.
But it also
We're gonna
tell you
have
how
it
well they've done, and like
Yeah.
how the movement's gone, and
Yes.
they give you all that data.
Yeah.
My name is Dr. Rastegopana. I'm from UCL and we are based in the hospital. So what we are doing actually is augmented reality. Right now we have the bone model here.
So I've got a computer screen,
That's correct.
and on that screen we've got
Different kind of models. So right now we can see the pelvis model right now here, but we can, for example, have the soft tissues like heart, like kidney, or any other soft tissues here. Just to show the concept actually, you can see here we have a robot here.
so next to the computer on the desk.
Yes,
We've got a small robot.
That's correct, yeah. Okay, I can manipulate the end effector of the robot and I can move it all around the model, so you can try it actually and you can get
It's a
the
bit
feeling.
like a pen, but
That's correct.
isn't it? And
So
it's a bit like using a mobile mouse on a computer.
That's correct.
Yeah.
But actually that mobile mouse can be used for example, laser cutting, can be used as a different kind of tools during the surgery.
Right.
So that you can get the force feedback from that device and you can see and visualize actually the model from here. So the main purpose actually here is training purposes in order to get idea about the shape, about the structure, about the material which is used in different kind of bones, for example here in pelvis. But if we look at from different angle, we can see that this device can be used as a tool to cut, for example, bone, or if there is a tumor somewhere, we can use that end effector or that robot by using different kind of buttons actually to remove that tumor from the bone, actually attached to the bone. So there are many applications, and right now we are looking specifically in medicine and also in rehabilitation engineering how we can use these kind of devices.
And what about these goggles that you've got? So these look a bit like snorkeling goggles.
That's correct. So, yeah, put them on. Okay. Okay, now could you please hold the paper for me? Okay.
Right, so I've got these enormous snorkeling type goggles over my eyes.
Right.
And I'm holding up in front of me a piece of paper with some writing on it.
That's correct, actually. So you can see the model of the bone on a piece of paper right now.
Yes.
So right now you can look at that bone from different angles. So if you move that, you can see actually the bone from different angles.
So I'm seeing in front of me a bone.
Yep.
What the goggles are producing this bone.
That's correct. Yeah, that's correct.
They're projecting it.
Right now, if you give me your right arm, hold the paper with left arm, and give me your arm. And right now you have the tool that you can manipulate it.
Oh, I see.
Alright, okay. So right now you can get the idea about the stiffness of the material, about the shape of the material by moving that tool.
So what I'm actually seeing is it's similar to what we saw on the screen, but it's much closer. It's a much more intense image. So I could actually do it through these goggles rather than just on the screen.
Exactly.
Wow.
Exactly.
Gosh, that's amazing. So why on the goggles and not on the screen?
So we have both options actually, to using the goggle or using the monitor. So monitor, imagine that we are in an operation room. There is a big monitor there that all nurses, surgeons, they can see what's happening. And the surgeon is specifically using that goggle to manipulate actually.
Wow, okay.
So there are different possibilities to use actually virtual environment and integrate it with robotic system that we have.
Okay, brilliant. Thank you very much.
You're welcome.
I've got Maggie Philbin with me, and she's CEO of an organisation called Teen Tech. Maggie, tell me something a little bit about Teen Tech.
Well, the aim of Teen Tech is to help young people understand the careers of tomorrow, and with sort of RNOH as an example, it's very easy for young people and indeed their teachers and parents to think that working in a hospital involves being either a doctor, a surgeon, a porter, the things that they've seen on the telly, whereas actually there's a massive range of careers at many different entry points, everyone working together to make this hospital as brilliant as it is. So what we want to do is to help young people understand the opportunities, but most important, to see why they might very much enjoy working in areas that they may have dismissed as being not for me, I'm not clever enough, it might be boring, just to see what the possibilities really are.
How long has the organisation been running?
We ran our very first event in 2008. It was never intended to become a thing, but it developed a life of its own. And so now we work face to face with around 10,000 young people every year, and indirectly via our school resources with many thousands more. And there are a number of different initiatives, they're all age appropriate. So we have Teen Tech City of Tomorrow for the younger students. We have the Teen Tech Award Programme for the 11 to 19-year-olds. We have Teen Tech events. And we also help teachers and parents and students understand about opportunities like this open day, because being able to step inside an organisation and really see what it does, but also what the people who work there are like, makes it very much more real. And it means that both the kids who attend, but the teachers can go back, and when they talk about working within health, for instance, they can visualize. Well, it's about things like being able to take 3D printing as far as possible. It's about that combination of design, engineering, biology, physics, data science that might go into the ultimate artificial limb. And if they've seen it and touched it, then it's so much easier for them to be able to share that opportunity with others.
We're in a hospital today in the RNOH, but it's not just hospital tech that we've been talking about here this morning. It's any area, I guess.
Yeah, it's a very broad area. So the thing I think that sometimes goes wrong in schools is that things like biology, physics, maths, they are siloed. And in reality, whether you're thinking about a career in the entertainment business or whether it's in transport or food, there are certain skills that cut right across these industries. One of the key skills is, of course, digital skills. We all need those. But what we really want young people to understand is that in the real world there aren't these neat little silos, and you might go and work for an organisation like GSK, but the kind of skills you develop would be just as applicable for Network Rail, and so it's helping, as I say, young people really understand that yes, it is helpful to pass exams, but by developing skills such as, the ability to feel confident when you're creating ideas, or to work in a team, or to be really tenacious and stick at something because you're sure that actually this will work out, that these skills are really useful, whatever you do. And kids don't always have enough time to develop those skills at school, and also because of our current rather formal examination system, they aren't recognised because it's quite hard to measure those things. The level of support we provide, so when students enter the Teen Tech Awards, we connect their school or their parents with mentors from industry, so they're not trying to develop projects on their own, because they would very rapidly get stuck and the idea would remain on a post-it note. But the reason we do that connecting piece, so either remotely, so there's sort of mentoring via Skype for students, or by connecting them to what we call innovation days like this one, it means that every single student and school who participate get real value out of what we're doing. It's obviously brilliant for the kids who get through to the Royal Society, win, go to Buckingham Palace or whatever. That's obviously going to be very inspiring. But what we think is important is working right the way at the very base of that triangle and connecting every single school and student with opportunities which can be life-changing. So for instance, 2 weeks ago there were some young teenagers in Brixton with an idea, and we connected them with the CTO of Disney in LA, and they had an hour of his time over Skype. Now that is something those kids will always remember. The advice was very useful. They've put in an amazing project, and the point is that they've gone further with that and have been inspired and have remembered things, and looking through their project, it's very touching because you can see the impact that conversation had on the students. And we always say that Teen Tech is for life, not for Christmas, and by having those connections with students and schools, we help them develop a network of opportunity they may not otherwise have had.
Don't forget, you can listen again to Brockley News by following the links from our website at radiobrockley.org. And you can now tune in to Brockley News Extra 5 days a week at midday for another chance to hear some of our recent interviews, plus on Monday nights at 8 p.m. If there's anything else you want to find out about the activities taking place here in the hospital, then do get in contact with us on extension 5483 or on our external line 020 8954 6591. Let us know and we'll try and cover anything on future editions of Brockley News. Up next on Radio Brockley, it's Bedside Bingo, your chance to win some Radio Brockley goodies with David Rauch. Then at 8 p.m, it's all your requests on the Sunday Request Show, hosted by Keith Reeve. Brockley News will return at the same time next week. From me, Sophie Horrocks, good night.